What's going on, people? So, I'm introducing a new sorting algorithm called a quick sort. You will, once again, you'll never use this in a real world environment because Java gives you the ability to implement sorting collections. But for the purpose of testing your coding skills, especially if you're going for a senior developer position, you might run across this particular question, how to implement a quick sort. And a quick sort is more efficient than a bubble sort, and it would probably be used for a data set that contains a huge amount of information because of the way that it implements the sorting algorithm, where it breaks down the unsorted collection into multiple parts, and then it does a recursive process of sorting on these parts. So let us begin with the quick sort. The first thing I'm going to do is create my class. Quick sort. My quick sort will have a main method. I know someone's going to ask, oh, why do you write out the main method instead of just selecting it when you create the class? It's because in a coding interview, I once got asked the question about, oh, what are the, how do you, I slipped up on answering the argument. What type of argument is passed into the main method? I slipped up because I was so accustomed to just creating the main method automatically that it just slipped my mind, and I was like, I just, you know, just slipped up. So now I just write it out. So now it's just in my mind. If I'm asked, I just know, oh, public static void main string array args. So that's why I just write it out. I write out the whole main method. So now let me create my method, which is going to be the quick sort. So quick sort will return a list of integers. So it's going to return a list of integers. So first thing we're going to do, like I said, the quicksort breaks the sort algorithm, the sort collection in half and sorts both sides. So the first thing I'm going to do is check to see if unsorted size less than 2. It means there's not enough data to sort. Alright, so now we have an unsorted array. First thing I want to do is just get a initial value called a pivot. Which will be the first value from my unsorted. Assuming that the unsorted is weighed for a large collection, might be weighed equally, and sometime it may not. So maybe the first value, it might equally the middle, maybe not, but we're going to get the first value as our pivot. Going to create 3 lists: upper, lower, and sorted lists. So we're creating 3 array lists. And next thing is now we're going to populate our lower and upper lists. So we're going to go through our unsorted lists. And the way we're going to populate our lower and upper, we're going to check it against the pivot. So if pivot, which is our initial value, we're going to change that to 1 because the pivot is our first. We already got the first element from the unsorted, which is the pivot. So as far as an index for the unsorted array, or list. For the unsorted list, we're going to start with the second element, which is element 1, because the pivot is the first element, which is element 0. So if pivot is greater than, the pivot value is greater than sorted So we're going to just check our pivot with every value from the unsorted and either add it to the lower or upper based off of lower upper. So this for loop is populating our upper and lower list. And from here, we're going to now populate our sorted list. So our sorted list is going to be a recursive call so we have our sorted list that we created. Add all, which adds a collection. So we add all and we do a quick sort. So we're adding our lower, we're doing a recursive call of our lower to make sure that it's sorted. Doing a recursive call of that, which is going to sort until it's completed. We're going to add our pivot value, which supposedly sits in the middle. And then we're going to do the same to our upper. Add all. Okay, so now we have our quick sort method completed. Next thing we're going to do is we're going to test a quick sort in our main method. Let's test our quick sort. Alright, so I'm going to create a list of unsorted. Okay. Next thing is we call our quick sort. Add our unsorted list as a parameter. Next thing we want to do, we want to print this out. We want to see the output. We want to see what's returned. So let's return the list. I want to return it further as a to array. And now I want to do an arrays to string. Now I want to print it out to the console. Okay, let's see if our quick sort works. Run it, run as Java application, and voila, we have sorted output. And that concludes the quick sort. So, you know, it's another sorting algorithm under your belt. If you want one of these high paying positions at say Google, Amazon, or some other programming, some other technology organization, financial, or you know, these are algorithms that you're gonna get tested on. So it's good to know how to do these. They're very simple, so you could just bring them up from memory. So you should put the time and effort into learning these various sorting algorithms, even though you will never utilize them in real life. So, but it's good for coding tests because they're going to use them against you if you don't know. You could be tight with your, you know, your knowledge and knowledge and depth of knowledge in answering questions, but if you can't complete these coding examples, then you're not going to get the position. With that, I say peace.